Hey, hi everyone, welcome back to this video on Cisco Packet Tracer, dynamic routing. Packet Tracer offers the same dynamic routing protocols for IPv6 or IPv6, EIGRP, and OSPF. We'll be configuring RIPv6 in the next section. Note that IPv6 does not represent RIP version 6. It is RIP for IPv6 addresses. For this exercise, we'll use the topology shown in the following screenshot. The additional IP assignment details alone are shown in the following table. Device interface IPv6 address or 2 fast Ethernet 1/0 2001 :10/64 or 3 fast Ethernet 0/0 2000:3 :1/64 fast Ethernet 0/1 2001:1 :24/64 PC2 fast Ethernet 2000:3 :2/64. We'll see how to configure RIP on one router, and you can do the same on the others. R1 config interface fast Ethernet 0/0 R1 config IPv6 address 2000:1 :1/64 R1 config if IPv6 RIP net 1 enable R1 config if IPv6 enable R1 config if interface fast Ethernet 0/1 R1 config if IPv6 address 2001 :10/64 R1 config if IPv6 RIP net 1 enable R1 config if IPv6 enable. Note that the IPv6 RIP command is used to enable RIP on a particular interface. Entering IPv6 RIP net 1 enable on the first interface begins the RIPv6 process. The net 1 string can be any name that can be used to name the RIP process. Once configured, use the usual diagnostic tool ping to simple PDU to check connectivity. To view the RIP database, use the following command: rsh IPv6 RIP database RIP process net 1 local RIP 2000:2 :4/64 metric 2 installed fast Ethernet 0/1/FE 80 :201 :97 FF FE 87 :E5A9 expires in 173 sec 2000 :3 :64 metric 3 installed fast Ethernet 0/1/FE 80 :201 :9 FF FE 87 :E5A9 expires in 173 sec 2001 :4/64 metric 2 fast Ethernet 0/0/FE 80 :201 :9 7 FF FE 87 :E5A9 expires in 173 sec 201 :1 :4/64 metric 2 installed fast Ethernet /1/FE 80 :201 :97 FF FE 87 :E5A9 expires in 173 sec RIP process link local RIB. Trace route of the packet trace the route of the packet to see the path it takes. PC tracer 2000 colon 3 double colon 2 tracing route to 2000 colon 3 double colon 2 over maximum of 30 hops. 1 ms, 32 ms, 31 ms, 2000 colon 1 double colon 1. 2, 50 ms, 50 ms, 63 ms, 2001 double colon 20. 3, 94 ms, 94 ms, 94 ms, 2001 colon 1 double colon 20. 4, 125 ms, 109 ms, 125 ms, 2000 colon 3 double colon 2 tracer complete. Using both IPv4 and IPv6. In this section, we'll see how to make IPv6 only hosts communicate with other IPv6 only hosts through IPv4 only devices. There are several methods for doing this. We'll discuss IPv6 over IPv4 tunneling using generic routing encapsulation, GRE. The GRE method encapsulates IPv6 packets within IPv4 packets and transports them over the IPv4 network. The receiving device decapsulates the packet and sends only the IPv6 information to the host. For this exercise, we'll use the following topology. For routing, we'll configure EIGRP on IPv4 interfaces for the tree routers and static routing on R2 and R3. We'll begin by configuring R1, which is the IPv4 only router. R1 config int fa0/0. R1 config if no shutdown. R1 config if IP add 10.0.0.1, 255.255.255.0, R1 config, int fa0/1, R1 config if no shutdown, R1 config if IP add 10.2.0.1, 255.255.255.0, R1 config router EIGRP1 router. R1 config router network 10.0.0.0. Now on router R2, we will configure IPv4 and IPv6 addresses and routing respectively. R2 config IPv6 unicast routing. R2 config int fa0/1. R2 config if no shutdown, R2 config if IPv6 add 2000:1 :1/64, R2 config router EIGRP1, R2 config router network 10.0.0.0, 0.0.0.255. Do the same for router R3. R3 config IPv6 unicast routing. R3 config int fa0/1. R3 config if no shutdown. R3 config if IPv6 add 2000:2 :1/64. R3 config int fa0/0. R3 config if no shutdown. R3 config if IP add 10.2.0.2 255.255.255.0. The only configuration left is the tunnel creation. For router 2, carry out the following list of commands. R2 config int tunnel 0. R2 config if tunnel source f0/0. R2 config if tunnel destination 10.2.0.2. R2 config if tunnel mode IPv6 IP. R2 config if IPv6 address 2010:1/64. Note that the destination IP is the IPv4 address of interface FA0/0 of R3. Configure the other end of the tunnel on router R3. R3 config int tunnel 0. R3 config if tunnel source F0/0. R3 config if tunnel destination 10.0.0.2. R3 config if tunnel mode IPv6 IP. R3 config if IPv6 address 2010:2/64. The only thing left now is to configure static IPv6 routes for the prefixes 2001:1:/64 and 2000:2:/64. R2 config IPv6 route 2000:2:/64 2010:2. R3 config IPv6 route 2000:1:/64 2010:1. Use the simple PDU tool to check connectivity between PC0 and PC1. Use the tracer command to find the path that the ICMPv6 protocol takes. PC tracer 2000:2:2 trace route to 2000:2:2 over a maximum of 30 hops. 0ms 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 2000:1:1 2 0ms 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 2010:2 3 0ms 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 2000:2:2 tracer complete. This shows the IPv6 packets going through the tunnel. Summary: in this chapter we learned how to use IPv6 with Packet Tracer. We saw how to configure IPv6 static and RIP routing, and also configured IPv6 only hosts to communicate over an IPv4 path by tunneling traffic. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.